I work at the University of Hawaii in the Hawaii Institute of Geophysics and Planetology, and I'll be working on building the payload that is going to go on InVADER. The payload is going to use 3 characterization techniques to try to evaluate the elemental, molecular, structural composition of the materials around the hydrothermal vent, and it also going to try to detect its biology. The 3 techniques that InVADER is going to use are Raman spectroscopy, leaves, and fluorescence. In Raman spectroscopy and leaves and fluorescence, we will use a laser to excite our samples. In Raman spectroscopy, we'll have a green laser we'll probably use that will have a frequency, and that will hit your sample. And as the laser hits your sample, you're probably seeing a laser pointer or something. Your sample is going to glow with the color of the laser, but a small amount of photons are going to come out with a different color. That's going to have a frequency, that's the frequency of a laser, plus minus the frequency of the vibrational modes of the molecules. The vibrational modes of the molecules come from vibration between atoms in the molecules that move back and forth, like in a spring. That has some energy that can be transferred to the laser. That will constitute the Raman, which is different than LIBS. LIBS stands for laser-induced breakdown spectroscopy, and is a kind of atomic spectroscopy in which the laser power is increased to hit the molecules that were bound like this, break them, so one atom goes one way, another atom goes another way, and then knock off the electrons from the atoms. And as the nucleus is in the center, the electrons will have different energy levels, and you can always knock one electron from one electronic level to the next, and as that relaxes, it'll emit a photon with the energy of the difference between those energy levels in the atoms. Those energy levels, energies of the atoms, these are called atomic emissions, are characteristic of every atom. So Raman will look at molecules, and LIBS will look at elements. And finally, the fluorescence will look at different excitation electronic levels of molecules to try to look for fast fluorescence and look for indications of life.